Hello friends, welcome back to the bench. Thank you very much for joining me. We have a 93 Mazda B2600 that has two injectors stuck open. Now, what does that mean? So, the easiest fault is one of these two transistors, this one or this one, are shorted. We have the replacement transistors in stock, so let's get the multimeter on screen. I keep forgetting to add that feature that you guys asked for, so it doesn't convert the units, which is too bad. I spent so much time on that unit conversion method, and people don't want it. That is too bad. Anyways, what do we have? So we're in resistance mode. So first let's check collector emitter, and we got 1.234 mega ohms, so we're good here. And the other transistors, I don't remember which injector was stuck open, but we're gonna check both anyways. Okay, so we are not shorted on the output stage. So let's see. So that tells me already that there's not gonna be a short on base. How do I know that? Well, first let's see if I was right. So let's check base number 1. It's essentially open. Oh, 600 ohms. That should be fine. And the other one, 600 ohms. So the reason I know the base is not going to be shorted is this is something that you just have to know about the ECM architecture when it comes to driving injectors. The transistor, the base, if we trace it all the way over here, I think it goes underneath. I think these are the two resistors. 4.7, or is it 47 ohms? 470 ohms. So these two transistors, one of them, I don't remember which one, but it is connected to our input power, input voltage, and it goes to the base of our transistor driving the injector. Then we have the second, that's a lost trace, we'll see, probably not. Then we have a second resistor, and that resistor actually is driven by, yeah, this should have been cleaned, we'll get there. The second resistor is driven by this transistor, so this is 2 injectors here and the other 2 injectors here, right? Once we clean it, it's going to be a little easier to see. So essentially, the way it works, the transistor is always open, and the MCU is cutting it out, is cutting off the fuel. Now, why is it done that way? Honestly, I'm not sure, but one explanation of why it's done that way is we had one ECM where this transistor was shorted. This one or this one, I don't remember. Thus, 2 injectors were not working. So if it shorts, then it permanently closes the output stage, the big transistor. The same with the MCU. If MCU output is shorted, it behaves the same way. The injector just doesn't work. But on the other hand, if you disconnect the base from the MCU, so if there's a broken trace somewhere over here, and we're gonna find it if that's the case, then the injector is stuck open, and that's what we have on this one. So the cap was replaced. We don't know when, but we do know how. Look at that. Not the best work. Look at this cold solder over here. I'm sure it looks better on the other side, but on this side, it looks awful. Let's remove it and see if this cap is still working. We don't know when it was done, so we'll see how degraded it is, if at all. Well, we have correct capacitance, huge ESR, 600 milliamps. That's pretty good, or pretty good. That's pretty big ESR. And we have 1.3% V-loss, so yeah, definitely the cap is ready to be replaced. Maybe not urgently, but also it looks like it's the cheapest Amazon cap that you can get. Well, maybe not the cheapest one. But yeah, this isn't something that I install. But even if that cap was completely missing, like right now, it still wouldn't explain why we have stack open injector. So this looks like conformal coding. You see now why I always clean them before I return them. You don't want to open it after a few years and see this. So let's just see what we can see over here. If it was broken trace, that would be great, because that would definitely explain why it doesn't work. Yeah, this looks like a trace is gone, but sometimes it looks that way, but it actually isn't. And this is pull up, I think. So even if this trace was missing over here, it wouldn't explain why the injector is stuck open. Would it? No, it wouldn't. It would be not opening at all, right? Because the ECM would be controlling the ground. It would be interrupting the transistor, but the transistor is permanently closed. So that wouldn't explain it. Hopefully it's one of the resistors that is faulty. Because if we cannot find anything over here, right? If all of these resistors are good, all of the traces are good, that means that our output of the MCU is faulty. And if that is the case, then there's virtually nothing we can do with this one. Because, replacing the MCU, that means, we're replacing the, what do you call it? The entire unit, the entire ECM. So it looks like it's gone over here, but it should be fine. Yeah, we've got connection here. They usually look like this, but then if you scrape a little bit over here, then you expose the trace there, right? So it is connected. Let's see over here, also good. So now we could do this with, well, it's not shorted. So the best option would be to just connect some power and just simulate the injection signal and see what's going on. Because if the simulation of the injection signal is tests out fine, right, it works, that means it's definitely the MCU that is at fault here. I mean, it could also be one of these transistors. Usually when they break, they short out. But sometimes they will just stop opening, essentially stop working, stop performing their function. I know you're gonna tell me something about this cap. I don't know why, but they always look this bad. And I see on other boards that were worked on before that a lot of people replaced this cap because it looks bad. I agree, but it still works. It's completely fine. I mean, we're gonna test it. Usually it works. I think it's, well, it's both of these. As you can see, they are, so we have base, collector, emitter, right? Emitters are sitting on the ground and collectors are connected to bases. So let's check first one. Let's switch to the beeper because I don't feel like checking the meter every time. So this should go to the base of one of those transistors. We don't know which one. This one. Oh no, we have 0.200 millivolts of, yeah, this one. And on this one we have 200 millivolts because between them, if you check between them, it'll be roughly 200 millivolts of, well, closer to 300 actually. So that's why it beeps. So don't just listen for beep, see if the actual reading is correct. So that was this one, and this one the same. So this one should go to this one. And it doesn't. Okay. So we have our culprit. Yeah, and we're not beeping on the other one. So if we check resistance, we're gonna have, what, like 600 ohms over here, or something like that. Almost 800 ohms, right? And it should be 0. Or was it the other? Am I checking the right one? Hang on. So how did I measure it before? Did I measure the wrong one? Maybe I measured the wrong one. So this is the one for this transistor. So this transistor is the left one. We can check on the pinout which one's which. No, that's the right one, this one. Yeah, we have 200 milliohms, which is kind of a lot, but it could be because hang on, let's check here. And okay, here's your problem. We are open here. So we have no connection between these two. Yeah. Okay, here's your problem. So this transistor, we can check which cylinders it supplies, but yeah, we don't necessarily have to. So it's either the via is corroded or the trace. Weird, but that's what it seems like. So this is the other one. We have 0.7 here, and come on. Yeah, this one's fine. And this one is not. We are open here. Okay, so we have our fault. So that's good because that means the MCU is working. Now let's also check the diode and see if the transistor is okay. So between the base and collector and emitter, because this is NPN, we should have a diode. We got 0.6 here, and to ground we have 0.6. So the transistor seems to be okay. All we are missing is the connection. But so we are connected here. So that's the explanation, right? So we have a pull-up is working. It connects to this via. This via connects to the transistor. So it's pulling up the base. So the transistor is open. But the MCU is unable to close it because it doesn't have the connection between these two. So what we are going to do first is dig out the board. We're gonna clean the board because we are professionals. So we clean our ECMs. We don't return them like this. Especially since, you know, these repairs usually cost decent money. I mean, nowadays you can get this repair. The board was definitely removed because someone over tightened the screws. You can always tell that someone inadequately replaced the board because you can't unscrew it. So you can order this repair nowadays even as low as like $175, $180, something like that. In my shop, it's 200, but that's the difference of quality of repair. You know, some people, I've had customers, not really customers, the customers that they took the car to the mechanic. The mechanic's yelling at me that I didn't test the ECM, right? But when I receive it and it doesn't say what's wrong with it, then I just, you know, make some assumptions. I don't have the ability to test it up. I've been trying to buy this truck for a year now. I can't find it anywhere. And people who do want to sell it, they want like ridiculous money for it. I understand it's a good truck and everything, but you know, you gotta be a little more reasonable. I'm not gonna pay, you know, $6,000 for a 91 truck or 93. So I cannot test them in the vehicle. But as you can see, we can do a lot of stuff, you know, other than that, and meaning measurements and stuff. And that case where the mechanic was yelling at me, I obviously refunded the customer and everything. I lost a few bucks on it, but that's fine. But that was the one that had shorted transistor. So this control transistor was shorted. So I replaced the transistor. I checked everything, everything's fine. There was no short or anything. But since that transistor shorted out, it probably also damaged the input, or in this case output, of the MCU. Which I did tell the customer that this could be a possibility. So if it doesn't work after this replacement, then, you know, there's nothing we can do, right? It's not that I can't fix it. It's just, you know, it's the equivalent. If I have to replace the MCU, then I need the donor MCU, which means I gotta buy an ECM for $500 or $600, right? So it's not like I, you know, can't diagnose it or anything. It just, that's how the diagnoses work. You just have to receive it and put it in the car and see if it works, right? And if it doesn't, then we go further. Did they put some glue again on it? God, please stop putting chemicals on the ECMs. Especially if you don't even understand why you're doing it. If it didn't come from the factory like that, don't put anything on it. I keep repeating myself, but people keep doing that. Well, by people, I mean technicians. I doubt it's the customer that did that, but yeah, there's definitely something was put over here and it turned into glue. Instead of conducting that heat from the heatsink to the chassis, now it's just gonna glue. So not only it holds it, but it also acts as an insulator rather than conductor. So don't do stuff like that, guys. Don't try to be smarter than the manufacturer of it. And I know a lot of manufacturers do a lot of stupid stuff, especially nowadays in the modern electronics. Sure, I fully understand, but this is tested design that's been working for decades now. No need to improve anything here. Let's check the, oh my goodness. Yeah, but that looks bad, but this is just flux, the natural rosin flux, I bet, right? They just didn't clean it, because why would you clean flux after yourself? That looks better, right? And you can tell that it just flown everywhere around the board. I mean, there are signs of cleaning, so yeah, they just didn't care. Yeah, well, it is no clean, I agree, but still, it doesn't look that great. Especially, well, this one doesn't have a sticker. You know, the reason I clean it and I try to make it look like new is because I put stickers on my ECMs. Oh my goodness. Yeah, the reason there's no sticker is because this was not a repair shop. Yeah, this was DIY. That's why. Yeah, I can't imagine a repair shop doing this. I mean, that happens sometimes. Not repair shops, just accept some stuff that they normally don't work on and just do what they can, right? Sure, I understand that. I accept some jobs that I'm not quite, familiar with or don't have experience in. And yeah, if someone who specializes in that looks at that, and they would say that, yeah, Raf doesn't know what he's doing. But so I understand that happens sometimes. But this is rather basic, right? Just remove the conformal coating before soldering. Otherwise, the solder is gonna mix with conformal coating, and that's what you get. Although it looks shiny. Actually, from this side, the soldering doesn't look bad. It's the other side that looks awful. This side. But as long as the via is okay, that's not a big problem. All right, fellas. So now we just need to put it in the ultrasonic cleaner, fix the trays, and replace some cups. Do some more measurements. We're gonna check. Although injection works fine on it, so I don't think we need to do anything over there. I was hoping that it was one of those transistors, because that would be maybe not quicker. Because still you have to clean it, you have to put new conformal coating on it and stuff. You don't want to return it like this, crusty, nasty, greenish, come on, it's not that hard to clean the ECM, right? All right, let's give it cleaning and let's fix it. Alrighty, everything's recapped. ECM is nice and shiny. That's how I like them. Like new, right? That's essentially how I like when they come out of my shop. Alright, so it looks like the only thing wrong with it was that one tiny, and it's not even via, right? And on the visual, I didn't see it. I didn't see anything wrong. So without actually measuring, we wouldn't have caught it. And this is actually the, that's the problem. If you send an ECM without description of an issue, right, and you just rely on me to actually find it, it might take a couple tries. So definitely always describe what the problem is, because usually when they come in without the description of the problem, I just, if I see it, I see it. But I probably wouldn't have caught that if I didn't know that injector is open. I wouldn't know that to check that, because it looked perfectly fine on visual. And obviously you can't, with every ECM, you can't really start testing every single trace, because that wouldn't be very much viable. We actually have another one coming with a very similar fault, or also the injector, I don't remember, also either stuck open or not opening at all. I think it was also stuck open. So it does happen. Usually you can tell. Usually there's plenty of corrosion on the board and stuff, but this one didn't really have much. Alrighty, that'll do. Let's put it back together and ship it back. If it still doesn't work, let me know, and we'll be continuing. But this should be the only issue. I don't think there's anything wrong with the MCU. Thank you guys very much for watching. I do appreciate you, and I shall see you guys in the next one.